Maxim Tsvetkov here again, reporting on the progress of Team 524 and our robot. A few months ago, in mid-September, the first organization came out with the First Tech Challenge Bowled Over. In this challenge we are required to collect racquetball balls and separating them from magnetic racquetball balls, and then scoring them into a crate or an off-field goal, and then bringing up the crate, flipping the crate to score the balls, bringing up the crate onto the lifting mechanism, and then lifting the crate up as high as we can for points. The way our robot does this, we start off by using the spinner mechanism. We use a spinner mechanism in the back to collect the balls that are, collects it, and then we move the ball up through our conveyor mechanism. This is our conveyor mechanism. The conveyor mechanism moves the ball up through the robot. The first problem that we hit while building this robot was that the racquetball balls are they're rubber, so they don't move very much if they're pushed against something. So what we did to combat this, we made cylindrical tubes that are free spinning so that when the racquetballs move up the conveyor belt, they aren't stopped by anything. Once the balls start moving up, they either move up and fall into the crate, or if they're a magnetic ball, which the sensor we have is at the bottom of the robot, the magnetic balls move in, the servo moves down, the continuous servo starts rotating, and the ball is moved into the magnetic ball storing mechanism. At this point, we can score the magnetic ball into the off-field goal by opening this up, spinning the Lego motor inside of the robot, and then hitting it down and then scoring it in. Otherwise, if they're normal balls in the crate, we have a threaded rod pressing mechanism inside of our arm here with the bolt moving that will easily grasp. We have room to drive into the crate, and then we can easily grasp the crate like so. At this point, we can move the crate up, and we can also turn it using a continuously rotating servo as needed. Once we lift the crate up, we can also drop it off on the lifting mechanism. Once the crate is on the lifting mechanism, we can lift up the crate. Our crate goes about 62 inches, which was the record for the qualifier that we were at this last Sunday. The crate keeps moving up and up until the arm hits a touch sensor, which it should do pretty soon. The arm hits the touch sensor and the crate stops. At this point, this is about 90 points. We were the highest scoring team in Northern California for these last two qualifiers. The last qualifier we actually won, and we now have a spot at the Northern California Championships. But even though this works well, and this was the highest any robot was able to lift up a crate, we're thinking about various ways to improve our robot, one of which is to completely change this scissor lift mechanism, because we've noticed that this is probably the highest a scissor lift can raise the crate. So we are thinking of more of a string and pulley type system with plexiglass moving up and down. Thanks for listening.